In this lesson, I'll show you how to write the equation of a parabola given its focus and directrix. This is when the axis of symmetry is vertical. The question reads, find the standard form of the equation of the parabola with focus at -3 and 5/2 is 2.5. And the directrix is y is equal to 11/2, which is 5.5. The first thing that I want to do is plot these points on an xy plane. I'll start with the focus. We're at -3 and 2.5. So -3 this way and 2.5 upwards. So we have a point right here, and I'll call it F. I'll also write down -3 and 2.5 for reference. Next, I'll plot the directrix. It's at 5.5. So 1, 2, 3, 4, 5.5 right here. That being said, we have two very important pieces of information, the directrix and the focus. Look at the following equation of a parabola. This is what you use when you know that the axis of symmetry is vertical. We have x minus h squared on the left side is equal to 4p bracket y minus k, where h and k represent the vertex. Now we don't know the vertex, but the vertex lies equidistant from this point down to this point. So the average of that point and that point gives us the vertex, the y-coordinate of the vertex. Let me demonstrate what I mean. We have a point right here at -3 and 2.5. We should also have a point right here at -3 and 5.5. So the average of 5.5 and 2.5 will give us the y-coordinate of the vertex. To find the average of any two numbers, you add them up and divide by 2. So let me do that math right here. 5.5 plus 2.5 divided by 2. Adding these up, we get 8/2, and that's 4. So the vertex has a k value or a y-coordinate that is 4. The x-coordinate has to be -3 because that's its axis of symmetry. Therefore, our vertex is at -3 and +4. We can use this information now to substitute it into this formula. Let me do that underneath. I have x minus h we found to be -3. Put that in parentheses, raise that to the power of 2, is equal to 4p, and I'll discuss what p means in a moment, y minus k, and that was 4. Let me simplify. I have x plus 3 raised to the power of 2 is equal to 4p y minus 4. Now to find p represents the distance from the vertex to the focus or directrix. So the distance from this point that we just found, it was 1, 2, 3, 4, -3 and 4. The distance from this point to either this red point or that blue point. All we have to do is subtract 4 and 2.5, or 5.5 and 4. Either or, whichever one you choose, you should end up with 1.5, and that represents our value for p. Now p has these absolutes, so if this happened to be, let's say, -1.5, just write down the positive version. So let me write down 1.5 into where I see p, and I'll multiply 4 times 1.5, which equals to 6. So 6 bracket y minus 4, and over here x plus 3 raised to the power of 2. Now one more thing. Before we can finalize our answer, we need to decide what symbol 6 should be. Is it going to be positive or negative? Now we're going to choose negative because when a parabola is opening downwards, which it would be given that the directrix is up here, if it's opening downwards, then that value has to be negative. So we have to put a negative value right there, and our final answer is what you see in red, and -6 as a factor here. Now in case you do not have a graph to visualize whether it's opening up or down, compare the values of k, which is the y-coordinate of the vertex, to that of the y-coordinate of the focus. If k is larger than that value, then you know that it is opening downwards. If k is less than that value, then it's opening upwards. In our case, k was 4, and the y-coordinate of the focus was 2.5. Because k was larger, we wrote down negative. So there you have it. That is how to write equations of a parabola given its focus and directrix.